Hello, everyone. Welcome to the fourth Asia Pacific Rail webinar. Hope you are all doing well. My name is Bastian. I'm part of the Asia Pacific Rail team, and we are very excited today to bring this week's sessions covering blockchain-based tokenization of railway infrastructure assets, with our speaker being Gerald Schinagl from ÖBB Austria. Before we start the session, we would like you to submit your questions in the Q&A section, which you can find at the bottom of your Zoom interface. So Gerald will be able to answer them at the end of his presentation. After the session, you will be sent an email asking for your feedback on the session, and we would greatly appreciate it if you could take the time to fill it in. Now, without further ado, I would like to hand over the session to Gerald.
Yeah, good morning from my side. Welcome all people. So I'm gonna go right into the talk. So let's see. So you see, I hope you see my presentation. Yeah. So I'm gonna talk about today about blockchain-based tokenization of railway infrastructure assets, as already said. And to start with, we are from ÖBB, that's the Austrian Federal Railways. So who are we, or my person? I'm working in a special team called DigiAttack. So we are responsible for digital innovation. And we are a dedicated team that has the purpose to develop digital potentials to real-world applications. We are reporting directly to our managing director of our sub-company we are located in, working with a challenging mindset, being an evolutionary organization and being organized by a holistic way. So we don't have a head of department or boss. So I'm more or less the spokesperson of this team, and we are a quite small and agile unit. So we are right now 13 persons who are doing digital innovation. So yeah, some words on blockchain, as it's the main topic. Everybody speaks about it, but what is it, or what is it in real? Yeah, blockchain, try to describe it for non-technicians, is a distributed, encrypted, tamper-proof journal that captures every change in a transparent way and saves it in a protected, similar to general ledger in bookkeeping. So that's a quite complex definition, and it doesn't really give us a lot of information. So let's try to wire it up. The nature of a journal. So it starts that in a blockchain, everything or the content that is usually stored in the blockchain is a transaction. So something that is like transfer something from A to B. So we see it started in bookkeeping, and these transactions are bundled similar to the pages of a book. These transactions in blockchain are then created in a block, so more or less bundled and hashed, and one block is connected with the previous block. So it's quite impossible or almost impossible to tamper with a blockchain. It's theoretically possible, but the things you need are quite high. And the number 3 is this is a distributed journal. So the blockchain, as we know, is not running on one simple computer or one server at one place. It's running on many different nodes distributed around the world if you want to. And there starts the problem that it's not just hacking, but also technology like different speeds of networks, lags, off and online situations, that the information on different nodes may differ. So there is a lot of logic inside to distinguish which node or which nodes really have the, like say, reality that is written down. And that's also where the right now a lot of the energy is going into, because it's the process that is based on guessing and mathematical solving mathematical problems. But there are other algorithms that are right now being distributed that work better in that way. So a blockchain needs, as we said, consensus, and the consensus algorithms are a big topic where research is going on right now. So why is blockchain interesting for us in railway technology? It has a lot of attributes, but three of them are very interesting for us. One is it's almost tamper-proof. So changing data after it's persisted in the block is, as I said, theoretically possible, but needs an enormous amount of energy and planning. So you need to take over 50% plus one node in one instant, and do a lot of calculations. So yeah, theoretically you can do it, but practically it's not done. So we have a technical solution that is really providing information that cannot be changed in any event, that cannot be updated or deleted if somebody wants or needs to. The second important thing is that a blockchain, if you're doing it in a hybrid way or a public way, doesn't belong to one entity, but to all users. So it makes it the ideal platform if the companies do not trust each other, or if we are running in the situation that each company says, yeah, I have my solution and you should work in my solution, and the other company says the same. So it's a deadlock situation sometimes. And with a solution that does not belong to one company, sometimes this things can be solved much better and much easier. And number three, with blockchains up the second generation, so starting with Ethereum, for example, contain a thing that's called smart contracts. So that is program code that is stored in the blockchain, and that is executed once certain circumstances are coming in. And these smart contracts cannot be stopped. So if you have a condition, say something happens, then the smart contracts are running no matter what you're doing. So this is a very interesting solution to make sure something is executed. It's guaranteed executed, and it does not need an intermediary or some other situation. And this program code, as it's stored in the blockchain, is also, like in point one, immutable. So it's also made sure that there is no way to hack around the smart contracts. Usually would say it's quite sure there are some loopholes. So like always in IT, with the rollout of technology and with more and more hackers are going around, you find the loopholes and they are closed. And most of them are like not technology loopholes, but more logistic and methodical loopholes. Yeah, blockchain, some words on reality, because when you're reading in the books or in the newspapers or articles, you would guess that it's a solution that solves all your business problems, should be done now, and you're happy. But the reality is the maturity and experience is not yet given. There's a very fast development, a lot of changes, a lot of new things, a lot of additions are coming in. So the technology is still ripening, that it's getting enterprise ready. And as it's new and fresh technology, the operational knowledge is in basic condition, how to operate the node, what to do. And also some challenges, like a blockchain by its design is growing indefinitely, or wallets can be blocked. There is some, I would say, some things in that prevent it from a very broad usage right now. So the people are working on that. And we are still missing market standards. So it's a very open world right now. And if you want to do something with it, implementation capacities are quite scarce. So you're getting a consultant who tells you what blockchain does and how good it is very fast. But if you say like, I want to have something implemented, there is one blockchain center we have around half of the globe on the other side of the world. And right now that's a big challenge. And of course, a cultural change is needed. So blockchains only show their power in multi-party solutions. Blockchains are not a good replacement for classical databases or things like that. They are really to show their strength once you have many parties where you have like partially relationships, partially trust or no trust, then they are really good. And as I said already, it's not a remedy for every business problem. It's for some specific business problems that you should solve with it. Yeah, the second part of the title of the talk was the secondary lines. So as I will be explaining, we're doing a project with blockchain on secondary lines. So what's so specific about them? Secondary lines are tracks that are operated or usually operated with lower density and lower speeds. So it's operated with greater headways and quite often with smaller or compact EMUs. The wish or the idea is that the track network is characterized by a lower maintenance intensity compared to main lines. Doesn't work out every time. And it's a network with many infrastructure owners, especially like in Austria, we have many feeder lines where companies or greater units have their own tracks to do cargo logistics. So in reality, you don't have just a big track owner, in our case, ÖBB infrastructure, but many partially owners. And until right now, they are managed differently. So every company is managing their simple piece of feeder line they have individually. And that's not a good solution right now. And also a quite demanding influence is the nature. As you see on this picture, secondary lines tend to be much closer to nature, to vegetation. So it's more prone to be influenced by that trees are, for example, falling on the tracks or something is breaking. So they are quite more influenced by that. So yeah, the challenge is with secondary lines right now is it's a ample and quite complex infrastructure that we need to have available constantly, of course. That's the demand. We want to do railway operations continuously on these tracks, and they are sometimes quite large. So we are having high maintenance requirements, a big influence of nature that impair the operations and availability. And the resulting operation costs quite often prohibit an easy and attractive infrastructure usage, because until now, these secondary lines are quite often operated with technology that you also use on the main lines that is sometimes over exaggerated for the secondary lines, resulting in a lot of cost and a lot of complexity, and so making these tracks very expensive. So we are doing a lot of projects there in our department. So besides the solution I'm gonna talk about in the next minutes, of course, we are doing things like predictive maintenance, like management of natural hazards. So we're trying to predict or first to measure and then to predict when trees are prone to fall on the tracks, so to remove them beforehand, and to plan the maintenance also according to usage and to what is really needed, so to get into a more effective usage of these lines. And with the blockchain solution, we are trying to implement a lean idea of how an actual secondary line can be operated. So the arising demands we are having in Austria is that we are seeing an increasing need for transport capacities for commuters. So secondary lines quite often bring the working people from the outskirts or suburbs into the town. We'll see how that will change or will develop after the COVID. We're having an increasing trend to support decarbonization initiatives, and railways is a way to do that, as most of the lines are electrified. The politics, of course, want to tether remote areas better to urban centers. And of course, passengers request a more agile and dynamic means of transport. So the working environment is getting more and more agile, more and more dynamic. And so they also need their transport to be in that way. Secondary lines that have like 5 trains a day, 2 in the morning, 3 in the afternoon, 1 in the evening, will not fulfill this. So, yeah. So what we're doing is right now we're having a project to use blockchain as a possibly suitable approach for this challenge. So yes, why? Why can blockchain be a sustainable foundation of an operation for secondary lines? First of all, I'd said it's neutral. It's non-monocratic and multi-partner system. So we have a system that really allows us to include all the feeder line operators that are usually very hesitating to collaborate, because on the one hand, the big infrastructure provider has the system, we have a lot of complexity in the systems, and many of the feeder lines today are organized and operated by sheet and paper or by Excel sheet. So the hurdle for them would have been too big to come into traditional systems, but we think we can get them into a solution like that, especially into a solution that doesn't belong to one single entity. That transparency and tamper proving is inherent in the system helps also, especially in case when you're having legal problems, when accidents happen, when you have to prove that you did things right or have to prove what happened. So with a blockchain as foundation, everything that we are doing on this track is like locked and tamper-proof locked. The decentralized approach of the blockchain, of course, is an architectural foundation that helps us to get the system stable and prevent outages. So we're having many nodes operated that are substituting each other, and the token handling is built in and is a core feature of blockchain, of course, and it can be reflected by commercial transactions. So a token can be associated with a cryptocurrency or with values, or can be a simple reflection of physical reality, what we do in our case. So as I will line out a little later, we went back to the token handling system to operate tracks, and smart contracts are a quite good place for complexity reduction. We learned that a lot of rules, that a lot of logic is right now in switching centers, in steering centers, because beforehand there was no better place, but a logic in a steering center or a switching center is the most expensive place where it can be. So with smart contracts, we see the chance to put out some non-critical logic, some logic that is more in operations, more in optimization, put it out into a more IT environment. So we have on the one hand the chance to program it with more traditional programming languages and to do all the testing, regression testing, and automated testing in the classical IT way. So yeah, tokenization was the base idea that we took. And the idea of tokenization is not new to railways. The infrastructure usage was, and in some places on this earth still is, organized by physical tokens that make sure that their base requirements, so the exclusive usage of a piece of track, the safety, are met. So what we've done is we transferred the physical world into a virtual reality and blockchain, and built a so-called non-fungible token that is standardized. So it's a standard that's called ERC 721 that defines the base structure and behavior of a non-fungible token so that it works in a standardized way and can be also kind of exchanged and behaves in a predictable way. And it also enables us for an agile usage. So when you're having tokens in a blockchain, there is a way that you can do like trading, like clearing, means that for example, a token does not simply have to go from the infrastructure provider to the using railway or using train. It can also be traded between trains in case, for example, of delays or in case of capacity need. So it enables new business processes, new ideas, new markets, how infrastructure usage can be handled. Yeah, once you decided that you're doing something with blockchain in this world, it's not done with that, because there are many, many styles how you can implement blockchain. To be honest, we don't know yet which one is optimal. It's still a very early phase of all these initiatives. So we are learning by doing. It's a more research and try part. So the solutions are distinguished by the participants. So the base idea, if the loco or train is acting as a full node in the blockchain, having a computer in it and interacting directly with the blockchain, or if it is a controlled element by the blockchain. Also questions of the wallets. So who is holding the tokens? If you're having one wallet per infrastructure provider and railway undertaking, or one wallet per block. Also the depth of steering. So if you're doing steering and in the blockchain with like with a smart contract and bind the elements to the blockchain, or if you do steering traditionally in the control center, so that the control center is bound to the blockchain. Also the question where all this logic is situated can be in the blockchain, in a smart contract, can be in an off-chain situation. So the code is not in the blockchain, but connected with the blockchain, or the code can be in a traditional way in the systems where we had it. Also the question of interaction. So if this secondary line can be run as an encapsulated system where there is no interaction with others, or if the secondary line is connected to a like traditional main line that is operated by the, I would call it traditional means, by whatever it is. So if you're having to interact or not, and by the functions that you want to achieve. So if you're operating the secondary line in a traditional time-based operation, or if it should be run in a more agile ops, because with the solutions, there's always also the possibility to get rid of timetables, to do it in an agile process, like when there is demand for a train, when there is enough demand or demand for to stop on a place to do it, can be done in the blockchain. So our setup, how we built this solution, is that we, on the right side, you can see the block structure we implemented. So because it's quite complex with, as I said, technology is on the move, the solutions are evolving, the possibilities are evolving, and there is a lot of complexity in. We decided to go with the layer concept you're having in traditional internet. Traditional internet is, I would say, a very good idea, because it abstracts always the top layer, abstracts, that I put it out, the lower layers. So when you're serving to a website or when you're sending an email, you don't have to care about IP protocols, about servers, about nodes. And we also envisioned the solution to act like that. So we are going up from the layer 1, from the physical layer, so the tracks and switches out in the physical world, to a data link layer, a network layer, the transportation layer, session, presentation, application layer. Those layers are always connected to the lower ones by interfaces. And as far as possible, we try to implement those layers based on standards or industry standards that are here or evolving already. So this approach allows us to exchange individual layers. So when we're building this solution and during the build up, we learn that for layer 4, we have a new, better technology and better suited blockchain variety or whatever, then we have the chance to exchange that and not have to change the whole implementation. Generally, our setup is based on the continuous and exact location of the trains. So we are using so-called positioning providers that we are having also in usage for other purposes. So we know the exact location of each train at each moment. That is, yeah, in aviation, it is standard since a long time already. In railways, it's evolving now. By exact location, we really mean more than GPS exactly, because once when you have two tracks, usually the GPS is not exact enough to distinguish on which tracks, on the right one or on the left one, you are. So we're having some enhanced GPS variety there to get this out. So we know where the train is. And the second key part is that these train movements are not like points in time, but they are really vectors. So we know where the train is, we know where it is heading, we know its actual speed, we know if it's accelerating, decelerating. So we are calculating all this stuff in vectors and also predicting in vectors. Means that we can go into a more optimized situation where we, I would say, predict the future track usage. So as we said, the system is based on tokens. So these tokens are traded, and it's the trains are like consuming these tokens and making sure that they're exclusively using their piece of track they should use. But of course, to make it more optimized, we are having a token reservation or pre-reservation system, so that we know which train will need which token at which point in time. And for that, we are using the vector to calculate that. And out of that, the reality is, and that's the cost, the interesting part in terms of costs, is that by using such a way, we don't need electric signals at the track anymore. Because on the one hand, we know where the train is. On the other hand, the train or the train driver, depending on which variety you're running on, is getting the information. So we can get rid of a big part of a very expensive part of infrastructure, because not to forget, signals are need to be maintained, need to be inspected, need to be renewed. And So the only rest of signals we will need is some physical non-electric signals that are needed for legal compliance and for like emergency operations when signals are not working anymore. And as I lined out also, the driving order is securely transmitted to the locomotive. So in the first phase, it will be the train driver that is getting his driving order or his driving advice based on the system. But of course, once ATO is implemented, it can be also done by that. So what are we doing right now? We started a funding project. So it's a project that is bigly funded by the so-called FFG. That's a state-owned enterprise that is funding research and development. And so we're working there with some consortium partners from scientific organizations and economical organizations on the one hand to deepen the concepts I was talking about, and on implementation of a demonstrator, so to show and to prove that that the concept really works out. Number two we're doing is we're cooperating with rail partners. So Deutsche Bahn Systel has developed or is developing a solution. So we're discussing and evaluating their approach, and there is a lot of cooperation negotiations going on with them. So because as I said, there are different styles how you can implement the blockchain solution, and we all don't know yet which one is the best one. So it's good to speak with each other, to share experiences, and to finally get out the best of all worlds. And we are implementing it in a physical environment. So we are having a piece of track in Austria that is called Open Rail Lab, that is designated for future testing, for test the future of the railways. So you can do like ATO trials there, 5G trials there, and also our blockchain trials there. So we are having the physical layout we're having already. What we still need to push is the needed legal adaptations that we are allowed to do the trials, because with the laws right now, some of the trials wouldn't be possible. And so there needs, like with the trials for automotive drive in cars, it's the same in railways, that we are needing some adaptations. They were on the way right at the beginning of this year, but of course right now everything is stopped due to Corona. So we have to restart that process once we're getting into track again. And we, as the IT part, of course, are developing the technological capabilities, on the one hand, to operate blockchain nodes on our own, so that we know how to set up, how to run them, how to support them if something happens, if it doesn't work out the way we want to have them. But we are also having capabilities to do blockchain programming, because as I said, it's quite not so easy to get blockchain developers that really can work in a consortium setting. So we need developers, especially in the first phases, that are here at place. We'll see how that works out after Corona. So because we're going out to the Open Rail Lab, we are working with staff directly. And so we are building some capabilities on our own, so that we don't have to rely on some of the big companies to get that. Yeah, so that was I would say, yeah, quite sporty run through the presentation. So yeah, I'm open then for questions. I see 2 or 3 already coming in yesterday, and some on the line. So I'll first answer the questions that were put in before this talk. One question was what we are doing in digital innovation solutions for the rail infrastructure. Of course, the lean principle is one thing we are following. As you see with this solution, the idea is, or the theme and topic is how to get rid of elements of complexity. So the lean idea to reduce waste or to reduce that is a core principle. And as I said, a lot of predictive stuff. So we are using data quite heavily to predict what happens or what will happen on these tracks to optimize them. Then there was a question of the impact of blockchain on energy saving, on coach optimization, health and safety of passengers. Yeah, energy saving is I would say, a point you can discuss on, because on the one hand, blockchain in its implementations right now is quite energy consuming, but that is getting better every 1 or 2 months with new algorithms, with new solutions. So that is, I think, shouldn't be a problem in the near future. Where it helps us save energy is that it's giving us a holistic picture of the whole system. So as I lined out, we know where each train is, where it's heading, where it will be heading, should be heading, and that not just for one infrastructure provider, but for some more. So we are having the databases that we can do drive optimization, ideal drive, preventing accelerations, decelerations on that basis. And yeah, as we said, or as I lined out, we think that the core idea of the token concept will be a safe and secure one. And of course, the traceability is also essential. Then close to that was how do we use AI for these lean operations? Yeah, that's one thing I was lining out was the drive optimization, but in general, it's a base for AI, because with this solution, we are having like a real-time picture that is heading over or arching over different providers. And with this databases, much better decisions can be made and will be set up on this project. So I see. So I see there is some Q&A. So yeah. So the number one question is, what is the redundancy built into the system? Yeah, the redundancy is built, I would say, on the server side. It's built that we're using different nodes. So with many nodes, many connections, there is on the, let's say, on the backend side, some redundancy, where redundancy is still missing, or where the weak point is of course always when there is only one way of transmission of information and systems. That's also one of the ways where blockchain is coming in, because our trust issue here is not between parties. In a railway system like that, the parties know each other, but the trust is like, can we trust that our information is getting through? Can we trust that the information, a sensor on the switch or somewhere put in, is coming back? So we're working on that and try to figure that into the architecture and solution. So that's ongoing work, but a good point. So do you plan to have any backup system in case of failure, as headway can be affected? Yes, there is also needed to get it legally to get it into work is a backup system. So the backup system is, I would call it the classical way we are having it as backup also right now. So if the systems are not available anymore, it's driving on site and driving by instructions going over GSMR or any other communication means we will have in that time. So we're using the backup process we had already in place. That's also the reason why we need some physical markers instead of the signals to do this. Does it substitute the signaling system? What is the SIL level? Does it interact with the brake traction of the train? On the long term, on the long hand, I would say it should and can replace the signaling system. The working on the SIL level is one of the topics, especially the scientific part of the consortium has, because what we learned is that with the traditional definition of SIL levels or the checklists that you have, they don't work on blockchain. I'd say you can achieve some SIL level on blockchain, but you have to view it in a different way, have to check it in a different way. And that's why we are having an university in that is specifically working on that, how deep such a solution can reach a SIL level. And that's also the reason why in the first iteration, we give the driving order or driving advice to a train driver and don't interact with the train, because to reduce the risk, because it's we are going in a more step approach. So step one is to advise to tell the driver what to do, and only if that is working out with any bugs, then part by part we can think of going into the brake and traction system of the train. Because once we are there, then you're really in a deep interaction, and still some risk associated, and we want to go a step-by-step approach. Yeah. Then there was a question, are there any problems with the current state scalability of blockchain? Yes and no. One challenge is the blockchains are having the block times. So they're not really, or most of them, some are coming up, not really real-time systems by their core architecture, but there is a lot of I would say technologies and features around, so like a so-called lightning network and other stuff. So we think we can work with the scalability, but it's of course a topic you have to have very top on your list and have to look very closely, because that can really be the showstopper. So that's yeah, one good point. When the system is ready and running, do you believe it can be used to help capacity planning and track maintenance efficiency? Of course, we're expecting that, especially expecting that as this system will allow us a more integrated approach. As I said, many infrastructure providers, many things going on. So for example, a track maintenance in our case is a block of some tokens that cannot be sold or not be acquired at this time. And the system is working with that. So it's a dynamic system. So if some tokens are blocked, maybe by track maintenance, or also maybe that they are not available due to some natural problem, like some track is blocked or something broken or otherwise influenced. So there is a wayfinding logic inside, and when there is still an alternate way, the system works with that, calculates that, and takes it into account. So what do we have here? Is the system effective for track work as well? Examples such as cut and slew for temporary track diversion during isolation. Yeah, can be. So that's the idea. So that we're having tokens not just being traded between infrastructure provider and trains or train and train, but also that tokens can be temporarily put out of the system and like be blocked by some other entity for whatever reason. And it works with the traditional system. Yeah, that's one of the requirements we are having and one of the challenges, because also our test track, this so-called Open Rail Lab, has a connection to a main line. And so that's why we put, when you look on the layer logic, having a layer, an integration layer, because that's one of the ideas, that we are integrating with a system that has a traditional steering system that has different ways of how it works and how it can interact with each other. So yeah, we are building that in. Do you use a public or private blockchain? It's a private chain, of course. Public would be too risky. But it's I would say blockchains that are quite common. So we are working with Quorum, with Ethereum, also looking on Hyperledger, some of them, but all those in a private setting, of course. And one final question I see is, how will this interact with ERTMS, and will it meet the safety standards set by the ERA? Yeah, will is a good question. We are working on that. We try to achieve that, but as I said, it's a kind of research, a kind of learning project. We cannot be sure that it will be achievable, but of course we want to get as close as possible to that. So, can it be used for train maintenance? For train maintenance, good question. Yes and no. What it can be used, what makes it possibly interesting, is what we featured in is that it is not just taking the rolling traffic into account, but also what is quite common at secondary lines, that you're having some fixed, not traffic, fixed rail cars, like they are standing overnight, standing for maintenance at some track. And in the traditional systems, this is not taken into account, and we try to model that also, because it's needed to get the whole picture that we want to work with. Is the main benefit of this system the absence of electrical signals? Yeah, it's the main benefit. I would say financially said, on the short term, yes. That's yes, for the reason because it can be calculated very well. So the controllers can very easily calculate what it means to reduce these signals, the associated costs. But I would say the number two benefit is a more smooth and more how to name it, an environment that can be better optimized and better used. But that is a thing that is quite hard to calculate right now, what really the influence in terms of euros or dollars is. So yeah, we will see that after or while we do this project. So I think the Q&A doesn't tell me any more Q&As. So yeah, if you're having some more questions, feel free to put them in or to raise your hand. And if there is some interest to follow up, to go into deeper discussion, or if you're interested on our experiences, then just give us drop me an email and I will get into touch with you.
Okay, thank you so much, Gerald, for all your presentations, your insights, and answering all the questions. As mentioned, if you have any further questions, please feel free to reach out to Gerald directly. You can also look him up on LinkedIn. He's very active there, sharing posts and commenting, as I always see. This webinar, as well as our previous webinars, are available for download on the Asia Pacific Rail website. So please have a look there. And as you can see on screen, we are also very excited to announce next week's webinar, which is sponsored by Hexagon. The webinar will be featuring an exciting panel on cost and schedule performance that is centered around current challenges for today's railway projects. So please mark your calendars for Tuesday, May 12th, 3 p.m. Singapore time, and hopefully we will see you again then. Thank you again, Gerald, and stay safe, everybody. Bye-bye.
Bye-bye.